In this demonstration, you'll learn how to set up joints and joint properties using this model of a robotic arm. I have already set up several loads and constraints. First, I've set up a support to fix the base of the arm. I have also applied two displacements. The first pushes the arm down, and the second rotates it. In addition, I have defined 5 different contacts. You can see them here. I am now going to define my joints. First, I'll right-click to add a joint. Then, I'll select the faces for the base location of my joint and assign them in the Joints panel. Next, I'll select these faces and set them as the mobile location. I need to assign a joint behavior, which defines the behavioral properties of the joint. Because no joint behaviors exist yet, I'll create a new one here. If one existed, I could also select it. In the joint behavior, I'll set the joint type to hinge. Next, I'll add another joint here. I need to hide the link body in order to select the pin surface for the base location. Then, I can select the face and add it. I'll show all bodies, and then hide this body so I can access the link hole surface. Then, I'll select the face for the mobile location and add it. I'd like to use the joint behavior I specified for the previous joint. So instead of adding a new one, I'll select the one I've already created. Joint behaviors are designed to be independent of a specific joint, so you can apply them to multiple joints as needed for your physics solution. Now I'm going to skip ahead. As you can see, I have set up 3 additional hinge joints. I will now add a joint here at the bottom. I'll hide this body and select this face as my base location. I'll show all bodies again. Then hide the main part of the robot arm and select this face as the mobile location. Next, I'll add a new joint behavior for this joint. In the joint behavior, I'll set the joint type to general, and then set the joint to rotate freely around the z-axis. While this is, in essence, another hinge joint with free rotation about the z-axis, I've selected the general joint behavior to show how you can use this joint behavior to customize your joints. Now, I'll solve the physics solution task. Everything's updated, so now I can evaluate and view the results. I'm going to view the displacement magnitude result to see the result of the displacements we've set on this model. You can see that the model is being displaced in 2 directions. This concludes this demonstration of joints and joint properties in AIM.